Hello guys, so we are going to continue the discussion with respect to retrieval augmented generation. In this specific video, we are going to discuss about this very important topic like what are the differences between prompt engineering versus fine tuning versus RAG. Let me tell you guys because here there are a lot of confusion from many people. If there is prompt engineering, why should we go ahead with fine tuning, or why should we go ahead if there is fine tuning, why should we go ahead with RAG? Each and everything we will be specifically talking about. We'll also talk about how prompt engineering works, fine tuning works, RAG works, and we'll also talk about the pros and cons as we go ahead. Okay. So first of all, let's understand about prompt engineering. So as you all know, prompt engineering is more about giving a prompt to a base LLM, right? When I say base LLM, let's consider that this is one kind of LLM. It can be OpenAI GPT-4o LLM, or it can be Llama 3, it can be Google Gemini LLM. Let's say if I just go ahead and give a kind of prompt, okay? Let's say the prompt is like act as a chef and provide me a recipe, okay? Provide me a recipe. So if I give this information, okay? So this information is just like a prompt where I'm giving a kind of instruction to the LLM to behave in that way, okay? So based on this particular prompt, now whatever input I specifically give or whatever question I actually ask, I say that, hey, please tell me how to prepare pizza, right? So that is a kind of input, right? So based on like how a chef will give me an answer, it will go ahead and give you a customized output. Okay. So with respect to prompt engineering, it is very simple. We provide a prompt to our base LLM, and our LLM basically works based on that specific prompt. Okay. So here, the first thing is that we provide specific instruction in the prompt. Okay. Specific instruction in the prompt. Second, your prompt that you're giving should be very structured prompt. It should be a structured prompt with clear context. This is a really important statement. If the context is not clear, it will not be able to, the base LLM will not be able to give you a customized output. Okay. Then the third important main property is that the model will remain unchanged. Okay. The model is same, the same base LLM model. Okay. It is not going to change its parameters or anything as such. Now let's go ahead and talk about the pros of using this. Okay, pros of using the prompt engineering, right? So the prompt engineering part. So the first pro over here is that the first major advantage is that no technical expertise is needed, right? So here just a normal English language and you will be able to perform prompt, right? Prompt engineering, right? So no technical expertise is needed over here. Second, you will be able to get a quickly and instant results. Quickly and instant results. Third, here to write a prompt, when compared to fine tuning and RAG, there is no training cost involved, right? So no training is required, no additional training is required. It is completely for free, right? You can just go ahead and change the prompt itself and the LLM should be able to give you a customized output. Okay. Fourth important main property is that it works with any LLM. So you can go ahead and give your own prompt based on any kind of LLM, then it should be able to work. Okay. Then what are the cons? Because we need to also understand, if we know all the advantages, what are the disadvantages? Now, with respect to disadvantages, here, most of the base LLM models, it will be limited. It will have a limited base knowledge, So in this scenario, since we have a base LLM, it is always limited by models base knowledge. Base knowledge. So here we don't have any external information, right? So whatever model is basically trained with the previous data, only that information I have, right? Now, when we keep on changing prompt, right? Sometimes there are scenarios that we will get inconsistent results, right? So let's say if I go ahead and put a prompt on one LLM model, I may get a different result. I may just tweak that particular prompt, then again I will be getting a different result. So inconsistent result, this is the most important thing, inconsistent result. Okay, coming to the third important con, here always remember every model has a token limit restriction. So with respect to that particular point, I will go ahead and write it down over here. Token limit restrict complexity. Okay, so this is one specific point that I really want to mention. And the fourth important thing is that it can't add new knowledge. That's it, because we cannot add it. Here we are specifically using the base LLM, we are modifying the prompt and we are getting the output. Okay. Now, when should we specifically use prompt engineering? When should we focus on that? See, let's say that you want to quickly go ahead and check. So I'll just go ahead and give a statement what it is best for. Okay. So the first point here, I will say that if you are trying to do a small scale application, quickly do it. Try to do it with the help of prompt, because most of the use cases will be able to solve it for them. And definitely this is not suitable for, see, whenever we use some base LLM model, we are always going to get a generic answers, right? So not suitable for any company specific work. Let's say I want to create an AI assistant only for companies. At that point of time, I'll definitely not use prompt engineering. For that, I will either go ahead with fine tuning or RAG. Okay. So here it is. This is also used for generic public task or generic, I'm saying public, but it is just used for generic purpose task. Okay. Generic purpose. So all my answers will be mostly generic itself, right? Small scale application. Third is that I will also be using this for quickly doing my quick prototyping, right? So this can also be very, very helpful. So these are some of the points that we have specified here in the prompt engineering. We just give the prompt, and that prompt is combined with our base LLM. And whenever we give an input, we usually get a customized output. Okay. Now, the second thing is with respect to fine tuning, right? Now, fine tuning, why it is specifically necessary, So let's say that I have a company where I am planning to create an AI assistant, which should completely behave like how I want, each and every instruction that I am actually giving to the AI assistant, it should be very specific to my company. Let's say if there is a chat bot that I have actually created or an AI assistant that I have created, if I say, hi, well, it should probably reply you back that, hi, welcome to XYZ company. How may I help you? Can I provide you the services of this specific company? So here specifically, we are focusing on a company domain use case, right? It is completely like how my company actually wants that AI assistant. Similarly, I will be able to create it. Okay. So here, how we actually do the fine tuning. Okay. Now, with respect to fine tuning, it is nothing but here we basically say that we are going to teach the base LLM through training, right? So let's say that there is a base LLM model. What we do is that we get a new training data. This new training data will be the company training data. And then we try to train the base LLM with this specific training data. Once we train with this training data, obviously the LLMs usually they use different architecture, and there will be weights. That weights gets modified, right? It gets modified, and once we specifically take that modified weights and apply it into our LLM model, it is nothing but it is called as fine-tuned LLM model, right? So this is nothing but this is a specialized fine-tuned LLM model which will be specifically used by the company for their problem statement, right? So this is how entirely, and again, this is a very big process. Fine tuning techniques are there like Clora methods and all. But our course syllabus is mainly focused towards RAG, So here you'll be able to see that with respect to any companies who are specifically focusing in creating their own chatbot AI assistant, which will behave like what the company specifically want, that time we'll be using fine tuning itself. Okay. Now, first of all, we'll try to understand how it works, right? So for this, the first important thing is that we have to prepare, or what are the requirements? So we have to prepare domain specific training data, right? Domain specific training data. When I say domain specific training data, that basically means it is nothing but the company data for which we are basically creating the chatbot, right? Second is that we train model on the data, right? On company's data. So this is the second important point. Third is that model weights that are changing, right? They are permanent. They are permanently changed. It'll again, I'll not go back to my base LLM model. So once the training is done based on this new data, the weights will be completely modified. Okay. So it basically creates a specialized version. I can say that. Okay. Specialized version. So these are some of the important points. Now let's talk about the pros and cons, right? So that you will be able to get a very clear understanding what are the pros and cons with respect to this. So the first pro that I would like to talk about is that whenever you have specific specialized domain knowledge problem statement, right? At that point of time for a specific company, this will be very, very helpful, right? So specialized deeply specialized knowledge, right? You'll be able to create this kind of chatbot. Second, your chatbot will also have a very consistent behavior since we have trained this with our own data. Third, no prompt engineering needed, right? Here we specifically don't require any kind of prompt engineering because already my model has been trained with fine tuning data. It can uh, learn new writing styles, new behaviors, and it is always better for a specific domain, right? Let's say I want to create a chatbot assistant which is a legal expert. So what I will do, I will specifically train that model with only legal data, right? So that are some of the important pros that we can probably bring up while we are specifically creating AI assistant or LLMs by fine tuning. Okay. Now, obviously, if there are pros, there need to be some kind of cons. So what are some of the cons? So let's talk about this. What are some of the cons? So when with respect to the cons, the first important thing that I will be talking about, it is expensive, right? So the entire fine tuning process is expensive. Why? Because obviously we will be requiring GPUs in order to train all these specific models, right? Not suitable for a startup, who are having less funding and all, right? Obviously they don't want to spend a lot of monies with respect to fine tuning in GPUs, renting out GPUs itself. Second important thing is that over here, when you are trying to create a chatbot with the help of fine tuning, you require good expertise. So require ML expertise or Gen AI expertise. You definitely require this because the task in retraining an LLM model is very, very huge. Okay. Then regularly, again, once you start retraining your model, right? Regularly retraining is required. Definitely. Why? For updates. Once you train your model, right? Retraining is definitely required for updating your model again and again, right? So these are some of the cons, and that is the reason only companies, whenever it is only required, they will go ahead with fine tuning the entire models. But there are also companies who will be specifically doing all this stuff. Okay. Now finally, what it is best for, right? We need to understand that. Let's say I want to go ahead and provide some specific style in how my chatbot is behaving. I will definitely go ahead with fine tuning my entire AI assistant. Whenever I have huge data, high volume data, I should definitely go ahead with this. Because they are consistent task and all. And third, if I'm looking for where my accuracy should be very, very high, so definitely I will go ahead with fine tuning. So here, when accuracy matters, right? If accuracy does not matter much, If accuracy is critical, then definitely I will go ahead with fine tuning. So these were the differences between prompt engineering and fine tuning. Now comes RAG, right? So many things we have discussed. RAG simple is like you're teaching through retrieval, right? So here, let me just talk about this RAG. And from this particular diagram, you should be able to clearly understand. In a RAG, you definitely have some knowledge, external source. It can be a database, it can be APIs, it can be anything as such, right? Then based on the user query, we use the base LLM that is there. Based on this particular query, we retrieve the documents from this particular knowledge base, right? We retrieve the documents. Once we retrieve the documents, then we summarize that document, we augment that document, and finally we generate that specific response. So here you'll be able to see that there will be something like an external knowledge base where the data is actually put up, right? It can be APIs, it can be vector databases, it can be anything as such. It can be in-memory databases, it can be documents, it can be anything as such, right? So from there, we retrieve the documents, and then based on the user query. So now this user query, we try to match it up on various different metrics. Usually when I talk about this knowledge database, right, it is some kind of databases itself, specifically vector database. I'm not talking about third-party API also. I can go ahead and interact with other vector databases which are in the cloud by using APIs and all. But at the end of the day, here what you're trying to do is that you're able to retrieve some documents, and then you're able to enrich that documents, and finally you're able to get the output, right? So here, that is the most important property about RAG. Now let's talk about some of the important scenarios. So first important thing is that how it works. First of all the documents are stored in vector database. So we store documents in vector DB, right? Because at the end of the day, retriever is actually created from this. Second important point is that we retrieve relevant documents, relevant docs from DB by using queries, or like for each query, you can say for each query. But at the end of the day, similarity search is basically happening from that particular vector DB. Okay, retrieve relevant docs for each query. Now, the third important point over here is that it is very, very simple. Here you'll be able to see that LLM generates answer from context. Answer from context, right? So whatever context you specifically get, you are able to generate the answers. Now let's talk about the pros. So here I have my pros. So the first pros is that, say, why do we use RAG? Let's say if companies having some kind of information that is getting regularly updated, then we cannot just go ahead and do the fine tuning, right? There will be a lot of cost that will be specifically involved. So for this particular scenario, whenever there is some up to date information, always go ahead with RAG. So here I will say that it will always have up to date information, info, right? Second important thing is that no training required. This is the major cost, right? No training required. We don't have to train the base LLM because there will be huge number of parameters. When we talk about cost effective, it is also very, very cost effective. And based on the techniques of RAG, the accuracy is also very, very high. Accuracy is high, but not that high as fine tuning. But I think a good, like right now, the kind of RAGs that we are specifically able to see is quite amazing. So the accuracy is increasing again and again. Okay. The fifth important point is that it can also handle private or proprietary data, right? Proprietary data, because everything will be stored in some kind of databases. Okay. Now let's talk about cons. Cons is one thing, right? Obviously, the first con is that this requires an infrastructure setup. Infrastructure setup basically means obviously you need to have a vector database, and all this specific stuff. The second thing is that sometimes the retrieval quality affects results, right? Like how we are able to retrieve from the vector database, that will affect the results. Okay. Third, there is always a context window limitation. See, every LLM models will be having some kind of context window limitations. So based on that only, they'll be able to get the context from the retriever itself, right? There will be a limitation based on different models, right? Then other than this, you can also think for what all things it is best for. I will keep this as an assignment, but maximum number of use cases like customer support and all can be usually done. Real time data also can be updated in the vector database, and based on that you will be able to generate. So that was more about talking about prompt engineering. So guys, I have completely explained the differences between prompt engineering, fine tuning and RAG. What I've done is that one image also I've created it over here. Okay, which method you should use, what are the pros and cons, each and everything has been mentioned over here. You can just go ahead and see to this, very easily. If you're not able to understand my handwriting, the same thing I've written it over here step by step, which much more proper explanation, right? So I hope you like this particular video. I will see you in the next video. Thank you. Take care.